This is lesson 8.2, graphing rational functions. A rational function looks like this graph where you have kind of a lazy L in two separate corners, and they are kind of mirrors of each other in opposing corners of the coordinate plane. So today we're going to talk about graphing these rational functions. A rational function just means fractional. So the word ratio is in the word rational, and ratio means fraction. So the parent function for this is y equals 1 divided by x. So 1 divided by x is in the format of a fraction. When we graph this parent function, we're going to start off with putting your pen in the origin, but you're not going to make any dots, although I just did. You're not going to make any dots because the vertex, what's going to be called the vertex of a rational function, actually does not touch the graph. So we would start in the origin without making any dots, and then we're going to go up and to the right, up 1 over 1, and make a dot there, and then I'm going to go down and back 1 so that I have dots in opposing corners. And then all I'm going to do is make the lazy L through that dot and a lazy L through that dot. And that is the picture of the parent function for the rational function. Now, there's some new stuff here. One thing is that this x-axis right here is never touched by the graph. See how the red never touches the blue? And the y-axis here is also never touched by the red graph. So when you have lines like the y-axis or the x-axis where the graph does not cross, if it doesn't cross, it's called an asymptote. It's called an asymptote, and the word is spelled like this. Okay? So it's like asymmetrical, so it's asymptote. And the asymptote is where it does not cross. So how does that affect my domain and my range? Well, my domain is going to be all real numbers, except it doesn't touch the y-axis, which would be 0. So x does not equal 0. And for the range, it's going to be all real numbers, except for y doesn't touch 0 either because of the asymptote. So if I were to ask you where are the asymptotes for this graph, you would say one of them is at x equals 0, and one of them is at y equals 0, because those are the places that we have the do not equal to when we're describing the domain and the range. Alright, so let's try another one. And first of all, we have y equals 6 over x, and I'm going to rewrite this as y equals 6 times 1 over x. All I'm doing is I'm taking the 6 and I'm just moving it out to the front so that you can see that this is, it's kind of like the slope. So this is a stretch. It's going to be a stretch of 6. So when I set up my graph, I'm going to start at the origin, and then I'm going to follow my slope. So starting at the origin without putting a dot, just hovering at the origin, and I'm going to go up 6 and over 1. Wow, that's way up here. And I'm going to go in the opposite direction, so I'm going to go down 6 and over 1, which is way down here. And then in both cases, I'm going to make this lazy L. So let me extend my axis a little bit so you can see a little bit what's going to happen. So because this has been stretched, when I make the lazy L that goes through it, it's going to be a lot wider than my original graph was, which is why it's a stretch, because it stretches this out, stretches it further away from the origin. So now when I talk about the domain and I talk about the range, you can still see that my asymptotes are the x-axis and the y-axis. Those are the two lines that are not being crossed. So the domain is all real numbers except x does not equal 0, and the range is going to be all real numbers except y does not equal 0. So you're going to see this happen pretty frequently. If you have a number divided by x, then your domain and range is going to look just like this. Okay, let's try another one. This example has a few more steps to it, so let's rewrite it first. I'm going to write the -4 on the outside, and then I'm going to put 1 over x plus 2. Keep in mind x plus 2 right here, that's x world. So we're going to be looking at how does this shift and whatever else happens here. So let's just do one thing at a time. This negative right here, recall, means it's a reflection, just like the other graphs we've dealt with. The 4 right here, because it's a whole number, means it's going to be a stretch. That's not very good writing right there. Then the x plus 2, anything in x world is opposite, or your x lies. So x lies and says it's positive, so that really means it is left 2. And then at the end here I have -1, which means down 1. So in my steps, the first thing I'm going to do is go left 2 from the origin and down 1, and I'm going to hover there. I'm putting a little bit tiny dot so you can see where I am, but I'm not actually marking that. I'm just letting you see where it is. That's called your vertex. The vertex will not actually be touched, but it is kind of the center of where everything happens. So I went left 2 and down 1, and then now with my slope, since it's -4, I'm going to go down 4 places and write 1, so that's actually going to be a dot. And then from the vertex dot again, I'm going to go up 4 places and back 1, so they're in opposite corners. Now, what I'm going to do with this is show you that where the vertex is going to create your new asymptotes. It's not on the x-axis and it's not on the y-axis, so I'm going to dot it in so you can see the guidelines for where we're going to graph this. So when I actually put the graph on here, I'm going to go through my dot, I'm going to make a lazy L. I'm going to go through my dot, I'm going to make a lazy L, and you can see that I actually didn't draw it very well over here. Let me add to this one. Going through here kind of a little bit closer down. You can see that it's getting closer to where my dotted lines are, but it's not going to cross them. And those are my asymptotes, remember. So I have an asymptote right here, and I have an asymptote right here. And so the x value is the x value from this vertex, and the y value is the y value from this vertex. So when I do my domain and range, I'm going to say all real numbers, except x does not equal -2. How do I know that it's -2? Well, I shifted it left 2 places, so not -2. And then for my range, it's going to be all real numbers, except y does not equal -1. How do I know that it's -1? Because I shifted down 1 place. So left 2 and down 1, that affects my domain and my range. If I asked you to tell me where the asymptotes are, you would say that they're at x equals -2 and y equals -1, because that's the 2 places where my graph is not going to cross. Okay, so I want to kind of give you some steps to follow. As you go through the process, you're going to first of all start out at the origin always, but you're not going to put a dot there. You're just going to hover. I'll write the word hover. So hover at the origin. Then you're going to do your shifting left and right. It depends on if you have shifts left and right. Remember, that's in X world. So you're going to do left or right first. Then you're going to do up or down next. But those 2 shifts together create the vertex. So you start at the origin and you hover. You have no dot there. You shift right or left and up and down, and that's called the vertex. But again, you have no dot. We haven't made any dots yet. So I'm still hovering here. Then I'm going to use the slope to count out how far I'm going to go. And this time I finally put my dot. It's going to be on both sides of the y-axis or the y asymptote, whatever the y does not equal. And then you're going to draw a lazy L through each dot, and it's going to be in opposite corners. So one L will be upright and one L will be upside down. So these are the steps that you follow when you're drawing these graphs. So I have a problem for you to try on your own. you're going to graph this equation. Keep in mind the plus 2 means it's been shifted up 2. The x minus 3 means it's been shifted right 3. And your slope is just going to be 1. So try graphing this, put your lazy L's on there, and let me see how you do.